Alright, Mr. Keller, we're going to do this in one take. So, the first question is the frequency of the waves, and the frequency of the waves is 0.15 hertz, because you have 9 waves in 60 seconds, so when you divide that, you get 0.15 cycles per second. Number 3 is the velocity of the waves. For the velocity, we know that that 4 is velocity divided by the frequency. So if that's equal to 4, so velocity divided by 0.15. So you take 4 times 0.15 in order to get the velocity, and the velocity comes out to 0.6 meters per second. Number 6, we had to reflect from a fixed boundary. And I think that looks pretty correct. Number 7 is looking at harmonics of a Swiss horn. So we have the first, third, and fifth harmonics pictured there, and the wavelengths and frequencies are put there respectively. The wavelength is based on the length, which is 6.25 meters. So for the first wavelength, we have 4L. So 4 times 6.25 is 25 meters. For the next one, you have 4L over 3. So again, we have 25 over 3 is 8.3 repeating. And for the last one, we have 4L over 5. So we have 25 over 5, which you get 5 meters. And then for the next one, you're just taking velocity, which is 343 meters per second, over the wavelengths. And when you do that, you get the answers shown there. For 8, we're just trying to find the frequencies. So the frequencies are all velocity over wavelength. So again, we have the velocity of 343 meters per second. Over the wavelength, for the first harmonic, the wavelength is 3.6 meters. For the second one, the wavelength is 1.8 meters. And for the third harmonic, the wavelength is 1.2 meters. Alright. So now we're going over to number 10. Number 10 is a police car siren that's following you at 30 meters per second, and you're driving at 20 meters per second. So you add 20 meters to the top and 30 meters to the bottom. You have 1,500 times 363 over 373 yields 1,459.79 hertz is what you're hearing. In number 11, I forgot to account for the fact that an elephant has 4 feet and not just 1. So rather than being 55,000 over 0.026, it's 55,000 over 4 times 0.026, and that gives you 14,102.56 pascals. Number 14, B, we're trying to find the buoyant force. So the buoyant force is PGV. So we have the density, which is 1.17, force of gravity 10, and the volume, which is 0.8, and that all gives you 9.36 newtons. And they're trying to find the force of the upward force. So the force of gravity is negative 800, and the buoyant force is 9.36. So you just add those together, and the rest of it has to be the upward force. Now 15C is the total buoyant force. Well, the force of gravity is negative 44.16 newtons, so the force of the buoyant force has to be positive in the reciprocal. And D, we're trying to find the buoyant force again, so that's PGV. The density of water is 1,000 kilograms per meter cubed, times the force of gravity, which is 10, times volume, which is 0.1 cubed, and that all comes down to just 10 newtons. And then the last one, number 16, 16C, if the stopper slips out, what would be the initial velocity of the water through the hole? And so that's kind of like halfway through there, but we have 10,000 the buoyant force on the other side because of 1,000 times 10. A lot of stuff canceled out already, so we end up with the velocity is 4 meters per second.